Welcome everyone to our set series, the SSCE aspect. Today, we'll be treating using Venn diagram to solve two subset problems. For any two subsets, A and B, not disjoint, that is A intersection B not equals to empty set. N, which is number of element of A union B, is equals to the number of element of A plus the number of element of B minus number of element of A intersection B. Example, M and N are two sets such that the number of element of M is equal to 10 and the number of element of N is equal to 7 and the number of element of M union N is equal to 13. Find the number of element of M intersection N. The options are given. Solution. Applying to subset formula, here number of element of M union N is equals to number of element of M plus number of element of N minus number of element of their intersection, M and N. Substituting into the given formula, we have 13 will be equals to 10 plus 7 minus number of element of M intersection N. Simplifying, we have 13 will be equals to 17 minus number of element of M intersection N. I'm making the number of element of N intersection M the subject formula. We have N into M intersection N will be equals to 17 minus 13, which is equals to 4. Another example. Out of 30 candidates applying for a post, 17 have degrees, 15 diplomas, and 4 neither degrees nor diploma. How many of them have both? Solution. Let G represent degree, and P represent diploma, and X represent both. Next, we represent the given value by the Venn diagram below. Here we have the universal set, then the two subsets G and P. We number them. G is having 17, that's for degrees, and diploma P is having 15. Next, we put our X in their intersection, which is for both. Then we now represent each of the inner set subset. For G is 17 minus S, then for P is 15 minus X. Then if you observe carefully, it is stated that 4 neither degree nor diploma. Hence, you have the 4 outside the subset, but in the universal set. Applying the formula, we will have that 17 minus S plus X plus 15 minus S plus 4 is equals to 30. What we have just done is that everything inside the set, take note, we didn't take 17 two times. It's 17 minus S, then plus the S, then plus 15 minus S, plus the 4 that is outside. We equate it to the universal set, which is 30. Please take note of the procedure we are following. And when we simplify, we have 36 minus S will be equals to 30. Making X the subject formula, we have 36 minus 30 will be equals to S. And that is to say X is equals to 6. Another example. In a class of 64 students, each student offer either physics or mathematics or both. If 50 students offer mathematics, and the number of students offering mathematics only is twice the number of students offering physics only, how many students offer both subjects? Solution. Let M represent mathematics. Then from there, N of mathematics, the number of mathematics is equals to 50. Next, we let P represent physics. Then the number of students offering physics will be equals to a question mark. From here, we also know, given that the number of the universal set is equals to 64. Representing this in a Venn diagram, let the number of P intersection M be equals to S. Then Y will be equals to 15 minus X. If you look at our diagram we drew, we let Y be equals to those who will be offering mathematics only. And since the representation, we are told that Y is the same thing as 2Y. That is to say, those offering physics is twice those offering mathematics. Hence, you see Y and 2Y there. But from our analysis, which we have just given, that when we let number of P intersection M be equals to S, then Y will be equals to 50 minus S. Remembering our diagram, we have that P will still retain its position and M Plus mathematics, which is 50, will retain. Universal set still remain. But 2y will now be 2 into 50 minus s. Remember, we said y, we have concluded that y is equal to 50 minus s. And s is in intersection. Then y, where y was before, we now have 50 minus s. And summing it up the way we did before now, we now have 2 into, bracket open, 50 minus s, bracket close, plus x, plus 50 minus s will be equal to 64. What we have just done is we've added all the items in the Venn diagram, the items in the subset for P and their intersection, then the subset of M, then equating it to the universal set. Please take note of how it is done. Open up the bracket, we have 100 minus 2s plus 50 will be equal to 64. Collecting items together, we have 150 minus 64 will be equal to 2s. And that gives us 86 will be equal to 2s. X is equal to 43. Another example. In a class of 45 students, 32 offered physics, P, 28 offered government, G, and 12 did not offer any of the two subjects. I. Draw the Venn diagram to represent the information. I. How many students offer both physics and government? 3I. What is the number of P union G? Solution. Let the number of P intersection G be equals to X. Then we can represent the given information by a Venn diagram as shown below. Now, our Venn diagram, if you look very carefully, you will see P, already the letters were represented from the question. So P, which is physics, is 32. G, which is government, is 28. And the universal set, we are told, is 45 students. Now, if you look carefully, we have already said that the intersection P intersection G is equals to X. So X is the first thing we write, which is the intersection. Then next, we subtract X from 32, and we also subtract it from 28, represented there. But you will also inform that 12 did not offer any of the two subjects. Hence, 12 is written on its own in the universal set there. I. We are asked to find how many students offer both physics and government. In doing this, we are looking for X. Then, now summing up everything within the universal set and the subset, we have 32 minus S plus 28 minus S plus 12. Take note, the 12 must also be added, is equals to 45. Simplifying, we have 72 minus S will be equals to 45. Collecting items together, we have 72 minus 45 will be equals to S. And that simply means X is equals to 27. Number 3, we are asked to find number of the element of P union G. N of P union G is equals to, that is the two subsets joined together with the intersection. And that is 32 minus S plus 28 minus S. And that is equals to 60 minus S. Already we have gotten S, so that is 60 minus 27 equals to 33. Another example. From the Venn diagram below, find the value of X. The options are given. Solution. We equate everything in the box to the universal set. That simply means 3S minus 1 plus S plus 5S minus 2 plus 2 is equal to 8x. Simplifying, we have 9x minus 1 is equal to 8x. Connecting items together, we have 9x minus 8x will be equal to 1. And that simply means x is equal to 1. Another example. Every staff in an office owns either a Mercedes and or a Toyota car. 20 own Mercedes, 15 own Toyota, and 5 own both. How many staffers are there in the office? The options are given. Solution. Let M stand for Mercedes, while T stand for Toyota. Then the number of M is equal to 20 from the question. And the number of T, which is Toyota, is equals to 15. The number of those that own both Mercedes and Toyota, that is M intersection T, is equals to 5. And the number of the universal set is unknown, so which is equals to X. Representing this in a Venn diagram, as shown below, equating all the terms inside the universal set. Note how it is done. We have 20 minus 5 plus 5 plus 15 minus 5 is equals to X. Simplifying, we have 30 will be equals to X. We've come to the end of the teaching today on two subset Venn diagram illustrations to solve problems. Next, we have some exercises that are given on page 141 of the Hidden Fact in SSCE Mathematics. Please try your hands on the exercises. The answers are given at the answer section of the book, either in the hard copy or the soft copy displayed at the bottom of the screen. Thank you.